Hi everyone. What I really want to talk about today is an absolutely amazing data structure, which is called linked list. Linked list is a linear self-referential data structure that gives us the ability to store a collection of objects called nodes dynamically and uniquely in the memory. And you're probably thinking right now, what does a node mean? A node is a struct, which is a way to define a data type that consists of one or more other data types that is encapsulated together. What also self-referential mean is that all the variables that we declare inside a struct are called fields. And one of those fields is a pointer that is a type of the same struct. So with that being said, let me show you an example what a struct looks like in Python and C. I've gone ahead and prepared example of a struct in C. So we have here two fields. One is a pointer that is a type of the same struct. That is exactly what I mean by self-referential data structure, is that one of the fields inside the struct is a pointer that is a type of the same struct. Now, if we want to declare another pointer and we want to point another node and we want to point to that node, to the new node we allocated, we assign the address of that new node we created to this struct. Now we have another struct that is, or a field, excuse me, that is a type of integer. Now, the way we malloc a node in the memory, we use the function malloc in C, and we also use the size to get the size of struct itself. And we also have here a pointer that is named node that is a type of struct. Now, what the compiler gives us back is an address where that object in the memory. Now, node looks like this. Now, node it's pointing, the pointer node is pointing at an object that contains next and an element. And this is how it looks like in C. Now, with that being said, let's see an example of a struct in Python. I've also gone ahead and prepared example for us in Python. As we can see that once we have two fields, a pointer that is the type of the same struct, and then we also have a variable that is a type of integer. Now, in Python, the way we memory allocate the node as the following. We say node and we pass the 3 to the init function that would give us back a node that contains 3 and none. And we have a pointer node, we have a pointer that is named node, and which points to the node we just allocated. Now, if we want to memory allocate another node, we can say node 1, node 2, and then we pass, let's say 1 in here. Now node 2 points to this object that we just allocated with the value of 1. Now, if we want to point to that value, we can traverse to this node and set this node, this pointer variable, to point in here. Now, with that being said, let's try some examples to see what a linked list looks like in code. I've gone ahead and created a file and named it linkedlist.py since we're writing in Python. Now let's create a class node, and then define node self element and self.element is equal to element, and then self.next. Next is equal to none. And here we have another class called linked list. We name it linked list, and then define init. And then we made a mistake in here. We need two of those. And self.head is equal to none. And then we can define a function we can name it push. And then inside, hey, self, that contains parameter named element. And then if not, self.head, then we say, go ahead and dereference to the pointer self.head, and then access the field head and assign new node to it. Since we did not declare the pointer new node, that is a type of node struct. Now we have that, and once self.head does not contain or does contain an address that which is a null, which in here evaluates to false, and then we negate it to true. We get inside here, we set, and then we dereference back to the node, and then we access the field head, and then we assign what's inside a new node, which is an address that is a type of struct, which is a node. And then we return, we exit out of the function. Otherwise, we declare a pointer named cold that is a type of struct, a node struct, and then we dereference to the node struct, we access the field, and we get the address of that, and then we say while the address inside node is evaluates to true, which is not equal to null, go ahead and traverse the node by dereferencing to the node, and then access the field next, which is a pointer. And then once we're done, say node.next is equal to new node. Okay, now we get out of the function, and then let's also write a function where we can visit each element, each value of the node. So we want to be able to see the elements inside each node. So that would be defined. We can define a function called show nodes. That is self. And then I say node is equal to self.head. And then while node, it prints f node.element here, and is equal to there. And then let's dynamically and uniquely allocate the node in the memory by saying linked. We declare a pointer variable that is a type of the struct linked list. This is wrong. Oops. Now we say linked list. We can actually let's create an array of 5, 1, 2, 3, 4, and 5, and then we can iterate over that array or list, and then we can say linked dot push num. All right, let's save this. Oops. And then let's run it. So Python linked list dot py, and we forgot to call the linked list dot show nodes. So we can see all the elements of each node. All right, so this is what's going on next. And then we have this next in here. Let's go ahead and try to run it one more time. And we get this error. And the reason why is because we're not traversing node.next. There it is. Now let's try to define a function that we insert node by an index. Let's try inserting nodes by an index, and then define insert node by index. That would take self element, and then the index that we would like to insert the node to, and if not, self.head, then return linked list empty. Otherwise, we say node, we declare a pointer that is a type of node struct. And then we say that if the index is less than or equal to 1, so if the index that we pass to this function is less than or equal to 1, just insert it to the beginning of the node of the linked list. New node.next is equal to self.head, and then self.head is equal to new node. And then we get out of the function. Let's give ourselves a little bit of space. Otherwise, we declare a variable that is a type of integer. We assign 1 to it. And then we say node another pointer. And then we assign self.head, which is an address that is a type of the struct node. And then we say while counter +1 is not equal index and node.next, as long as the field, which is a pointer, contains an address that is not equal to none. Go ahead and traverse .next, the node, the linked list, excuse me, and then increment by 1. And if not node.next, then return index is too large. Or otherwise we say new node dot next is equal to node dot next, and then node dot next is equal to new node. And then once we're done, once we insert the node, we exit out of the function. Now, I know this is a little bit long in here in this function, but let's go over this function one more time. So we say if not self.head, if go ahead and dereference to the struct that accesses the field dot head, and if the field returns back an address that is equal to none, which is evaluates to false in here, go ahead and convert that to true and access inside this F statement and return linked list is empty. Now, if this if this does evaluate to true, and then this become false, we get added in here, and then we dynamically and uniquely allocate a node in the memory, and we have a pointer that is named new node that is a type of node struct. Now we say if index, if we pass a value that is equal to 1 or less, then then what do? We say, okay, we want to add it, we want to insert at the beginning of the node. We say, okay, new node, which is the one we declared in here, go ahead and dereference to that, access the field, and then go ahead and dereference to self.head and access the field and assign that address to this field next. And then say self.head. Now the new node is pointing exactly where head is pointing to. And then now say self.head is equal to the new node. And then we get out of the function, we exit. Otherwise, we declare a variable that is a type of integer, and then we assign 1 to it. And then the reason why is because I want to check one ahead of me if the index is the one in the next node. And then we declare a pointer that is a type of struct node. Then we say while counter +1 is not equal to the index that we get passed in here, and node.next. The reason why I say node.next is because if we are at the last node, there's nothing we check in front of us. That's it. There's no more node, because if this evaluates to none, then this becomes to false, and then it doesn't get inside the while loop. So if that's the case, to check if it's node.next, well, there's nothing in front of us. We already checked one node before that and say index is too large. Otherwise, we dereference to the new node. We dereference to this pointer. We access the field, and then we assign what node.next address, what node the .next pointer contain, and then we assign it to here, and then we say node.next is equal to the new node, and then we get out of the function. Now, let's go ahead and test this one and see what's going on. Insert by an index. Let's insert 10. Let's insert it at 1. Now save. Let's go ahead and say Python 3 linked list dot py, and then we get 10. Perfect. Now let's do another one. Let's say if we insert at 100, I'm not expecting to get anything because we stop in that while loop. And then we wouldn't get anything. So the 10 does not exist. So let's do maybe 3, and that would be the last example for this function. And then as we can see, 1, 2, 3, index 1, index 2, index 3, and then we insert that. Okay, that works. Perfect. Now let's create another example that deletes by an index. Let's go ahead and do a little bit space, and then we can say del node by index, and then we say self index, if not self.head as usual, and then we can say linked list. Linked list is empty. Otherwise, we say if index is less than or equal to 1, we say self.head is equal to self.head and return. Otherwise, we can say node is equal to self.head, and then counter is 1. And then let's go a little bit down. while counter plus 1 is not equal to index and node dot next, and then node is equal to node dot next, and then counter plus 1. And then the same thing if not node dot next, return index is too large. Otherwise, we say node dot next is equal to node dot next dot next. And then return, just exit out of the function. Okay, let's go over this function one more time. Again, we're kind of doing some redundancy in here, but we can write this better to eliminate redundancies. So that will be probably in my next video. So we're saying if self.head contains an address that is equal to none, go ahead and convert that to true and get inside this f statement and return. If this evaluates to false, go in here and check. Now, what are we saying in here? If an index is less than or equal to 1, say go ahead and dereference self.head and go ahead. I think we made a mistake in here. Dot next. I'm saying go ahead and dereference self.head and then go ahead again and dereference access the field next and assign it to self.head. So what we are doing, we're skipping the node what self.head is pointing to. We're pointing to the node after that. And then we exit out of the function. And here, if this evaluates to false, we declare a pointer named node that is a type of node struct, and then we dereference to the struct, and we access the field head, and then we point to whatever head is pointing to, which is the beginning of the node, and then we declare another variable that is a type of integer named counter. We assign 1 to it, and then we keep iterating. Now, if node.next, if not node.next, that means we are at the last node and we checked everything. If not, we say go ahead and dereference a node and access the field next. That would brings me back an address. It brings me back an address that is a type of node, that is a type of the struct node, and then go ahead and dereference that node and access the field and assign it to node.next, which is the node after that, and then we exit. Okay, now let's test this and see what we get. So we inserted 3 at 10 at index 3. Let's now do the same thing, but delete. Go ahead and delete that, save, get the terminal, say Python 3 linked list .py, and then we get an error. And why is that? Delete node by an index. Okay. Oops, we're not inserting. Okay, let's do this one more time. Let's run it. And then 10 is gone. Now let's delete another node, which is at, let's say, index 30, which in that case doesn't exist. I'm not expecting to get anything. Perfect. Now let's delete a node at 1. 1 is gone. How about 3? And 3 is gone. Okay, perfect. Now, what if we want to add a node by an index? So if I want to insert a node by an index, so we go ahead and traverse the entire linked list and we look for that target, a node that contains a target. Sorry, if we want to insert a node by a target, that's exactly what I meant. Sorry about that. So let's create this function, declare this function, define insert we'll call it insert by target, insert node by target, and then it'll take self, and then elements, and then the target, which is a node that contains this element. Again, if not self.head, we can say I'm just going to copy this one in here. Then if that evaluates to false, then we can say node, declare a pointer, and then we have an element. And then if target is equal to self.head.element, and new node dot next is equal to self.head.element. And then we can say self.head is equal to self.head is equal to new node. Let me give ourselves a little bit space. And then we get out of the function. Otherwise, we say node is equal to self.head. And then we read this while loop, node.next, while node.next, while the field next contains an address that does not equal to none, and then dot next dot element does not equal to target. Go ahead and traverse the linked list, and then if node dot next, or if not node dot next, then say return not found. Otherwise, we say new node dot next is equal to node dot next. Let me go a little bit up, and then node dot next is equal to new node, and then we return. Okay, let's go over this function one more time. We say if, again, go ahead and dereference that address and access the field head. If the address does equal to none, go ahead and convert that to true and get inside here and return this string here. Otherwise, go ahead and declare a pointer that is a type of the struct node and pass an element to it. And then we say if target is equal to self.head.element, and then we say new node.next, we dereference to new node.next, access the field next, and then we dereference to self.head and access the field dot element. And then we say self.head, go ahead and points to whatever new node is. Otherwise, we say we declare a pointer that is a type of the struct node, and then we traverse the linked list as long as node.next is not equal to none, and node.next.element is not equal to target. And then we traverse the linked list by assigning node.next or by setting node.next to node. And then if we are at the last node, which is there's no more node in front of me, and then we say that, which is if node.next is equal to none, go ahead and negate that and get in here and say, okay, we didn't find the node. Otherwise, we do the same thing that we saw in the other function, and we dereference to this address, access this field, node.next. We do the same thing. We dereference to node and access this field, and we assign it to the field next, and then we say whatever inside new node, which is an address that is a type of struct node, go ahead and assign it to the field next. Okay, now let's save it, and then let me copy the name of this function. linked list dot, and then let's insert, we delete, okay, let me go ahead and comment those. And then we say, go ahead and add by, add 9 by the target 4. Okay, Python 3 list dot py. There you go. We have 3 in here. Sorry, we have 9 in here, which is right there. 4 was in here before 9. Let's do by 10. There it is. Now let's do by 100, which we don't have any node that contains an element that equals to 100. There's nothing in here. Let's do 1. Okay, let's see. And topic has no attributes element. Okay, let's see what's going on in here. If target is equal self.head, no dot. Oh, it's right here. Okay, let's save that. Delete. There it is. We have 9 in here. All right, that's all for this video. I hope you guys have better understanding what linked list is. And if you have any question, please let me know and I will be happy to answer those questions. But for now, thank you for watching.